So then we have in the application of Q, we have actually seen that how Caesar cipher work. This is actually a very famous cipher. It was actually um, the concept was very simple, that every message you have, what do? You just shift the letters. Okay, so if the cipher key, there is a key that is constant amount k. So if the k is 5, A becomes F, B becomes G. If k is 4, A becomes E, B becomes the previous one. Okay, so same way. So the problem, what we did here using this, the concept of queues, okay, what we did, we actually improved, we have made an improvement of this Caesar cipher, a cipher that is actually old, of almost 1,000 years old. And using this queue, what we did, we actually improved this one. Okay, and you see, by using a repeating key, now we can have using a repeated key, what we can do, we can have a Caesar cipher that is far more improved and hard to break. Okay, so and we have discussed how this work. And today here, so we'll see the implementation of queues in single linked list and circular arrays. So our main focus is actually the circular array. Okay, so let's first go there. Okay, so we already have talked about how linked list works, so that is actually not that much of our concern. So we already have a very good way to represent the linked list. Okay, but the array is actually our concern. So let me first tell you what is the problem with one-ended array. Okay, so let's assume that if we actually implement what we're trying to do, okay, let's just focus on that one first. What we're trying to do here is that we are trying to implement queue. That means we know how queue work. I have already shown you that this is the way that you can use queue. Okay, so we already know how to use queue in one way. Okay, so that is done. Okay, so now we are trying to learn two other ways. Okay, one is using linked list, using circular arrays. So these are the two other ways we can actually implement queue. Now you might ask, sir, we have already one concept of how to use the queue, why we are learning two more? Okay, the answer is that to actually understand that which one will be better and why. Okay, sometimes what happens, the default queue that I have just shown you, okay, it actually becomes not efficient in some cases. Okay, so it's very rare, but in some cases this type of queue is actually is not that much efficient, especially when you want to store a large amount of data. Okay, let's assume that you want to actually store not only a simple number or character. What you want to do, you want to store a person's name, information, father's name, and many other informations. Okay, so in that case, what happens that we actually need to customize it a little bit. Okay, it's not a mandatory. Again, you can still use the normal queue if you feels it complicated, but for now, for the course, again, as I said, this is a curriculum of Waterloo, so let's just follow a bit. Okay, so there are two ways: single linked list and circular arrays. So we already know how linked list work. You have seen the code, so there's nothing to worry about that. In the linked list, we just add node, and what do? We actually delete node. Now to implement in the queue, what do? We know that in the queue we add first and we add at the back and remove from the first. So what we can do in the linked list, we can just insert element. Okay, so it will automatically insert at the last. Okay, so this is done. So inserting is not a problem. Okay, normally it works like a queue, but whenever we delete an element, we just have to delete the head, okay, and update the head. So if I actually take a picture of how queue work in the linked list, so let's assume these are actually our small nodes in the linked list. Okay, so whenever a new node comes, what will happen? The new node will automatically, and we know that linked list actually last node is null, so we have seen that in the linked list we actually look for the next available location, and then we actually connect each node to the next one. So this is how the linked list goes, right? So whenever a new node comes, what we will do, we'll actually connect the new node to the last one. Okay, so that's it. Okay, and whenever we want to delete a node, we have seen that we use a head pointer, so head. So what we do, we actually use the head equals to head next. Okay, so I have explained this code in the linked list video. If you don't understand, go back and see it from there. So when I write head equals to head next, what happens? The head, which was actually pointing to this one, okay, instead of pointing to this one, it actually points now to this one. And then what we do, we just delete this node. So head becomes this one becomes the new head, okay, and then we delete the node, or we can say the delete or free head. Okay, so this is actually a very easy method for so for using linked list in the queue. So basically you don't have to change anything. Okay, the linked list is already almost like a queue format. All you have to do is just delete the head and update it. So I hope I'm very clear about this. Okay, so the linked list using it actually becomes very easy. And another advantage is, in linked list we already create a custom node, so we don't have to actually worry about that. The code is there. You can actually add multiple data to the node. So we normally whenever we are actually practicing in the class, what we did in the class, we only actually added uh, a simple integer data. But we have seen that you can, if you want, you can add more data to that, just like the class. So the linked list implementation for the queue is almost same. There's no difference. Just what is the difference in the circular in one-ended array? So in the one normal array, okay, what happens that let's assume the array capacity is 16. Okay, and you have performed one push after another push. So if you perform 16 pushes, what will happen? Okay, all the elements will be full, right? So you have inserted 16 elements. Okay, so all the elements will be full. Then if you perform 5 pops, what will happen? The first 5 elements will be deleted. So far it's normal. Okay, so we have used an one-ended array. We have first inserted 16 elements and the array is full, and then we have popped 5 elements. Pop means delete, push means insert. So you have deleted 5. Now what happens is that now if you want to insert another element, where you will insert the element? You have already reached you see the last of the array. There is no empty space left. So how can you perform further push? Even though there are 5 space left here, if you insert the element into this location, this will actually break the serial of the array. Okay, because we have to keep thinking that this is the first, this is the second, third, like this, right? So this is the problem with one-ended array. The array is not full, yet we cannot place any more objects in the array. We have 5 empty spaces and still we cannot insert any object in the array. Now I have a question for Minu. Mahfuza Minu? Hello? Hello? Okay, I guess.
Yes, sir.
Yeah, so Minu, can you explain to your friends that what is the problem here with one-ended array? I have just explained, so you just have to explain it back again. You can speak in Bangla if you want. Hello, are you here?
Hello, sir.
Yes. Did you understand? Did you hear the question? Hello? Okay, we don't have
Sorry,
much time.
sir.
Okay, so let me repeat one more time. We don't have any question. So now let's assume we have an array of 16. Okay, so what we did, we inserted 16 elements. So the array is full. And then we have performed 5 pops. That means we deleted 5 elements. So what will happen? The first 5 will be deleted. Okay, this 5 will be deleted. 1, 2, 3, 4, 5. Now, then if I want, there are 5 empty spaces, right? So if I want to insert a new element, what happens? That I have to insert here, right? After the 15th element. But there is no space left. So even though I have 5 spaces left here, okay, even the array is not full, yet we cannot place any more objects in the array. So that is the problem with one-ended array. Okay, because if I want to insert here, okay, there is no space after this. So to solve this, okay, to solve this problem, okay, what we did, we created another concept. That concept is called circular array. So how circular array work? So the concept is very simple. In the circular array, you see, instead of keeping the array in this way, what we do, we actually connect the last part with the first part. So what happens? It actually becomes one array with a circular in shape. So what is the advantage of, you see, using this shape? The advantage is that you see the last part of the array and the first part of the array, that means array 0 and array index 15 are connected. So what happens that now all you have to do is update the front and back. And there will be a question about this topic in the exam, okay, that I can show you for sure. So let me go to that question. So we have seen that this is a circular array, and we'll see how this circular array work. Okay, so let me actually take, let me see whether I have an example here. So first of all, let me just show you here. Yes, this one. So let's assume that I have a circular array like this. Okay, I will take a smaller array. So let's assume that I have an this is a circular array, and in the circular array I have only 4 space. Okay, just I have mentioned 4. So this is index. Let's assume this is the index 1. This is index 2. Sorry, this is index 3, and this is index 0. So I have only 4 spaces. Whenever I insert an element, this will go to the first. So let's just insert element. So operation 1, okay, insert A. So what will happen, this array, okay, initially it will have a 2 pointer, front. F means front, okay, and this means tail. Okay, that means the end of the array. So this will sorry, not this one, this will points to tail. That means the array start from 0 location, array ends at 0 location. Now you might ask me question, sir, why they are both in 0 location? Because right now I don't have any element in the array. So the first operation, if I insert, let's I means insert or push, insert A. So what will happen, the array will change. So now I will actually only focus on the changes. Okay, so let's see if you can actually get clear idea. So now I have this array, okay, of 4 elements, 0 1 2 3. Okay, I am trying to insert A. So what will happen after I insert A, I will write it here. Okay, this 0 location, that is the front location, will be inserted A. And what will be the change? The change will be, okay, the tail will also be 0. Just in this time, okay, what we did, we actually inserted an element. So this tail, the value of tail, what we will do, we'll actually change it to the next location, the next empty space, that is here. So tail will always point to the last element of the array or the next empty space. And there are 2 ways we can do this. For now, let's assume it will be point to the next empty space. Then I have assume another, insert another one, array B, insert B. So what will happen, B will be inserted here. Look closely, the value of front is not updated. Front is still pointing to 0 because the Q starts from 0 location. Tail is pointing to B. So as I have said just a little bit ago, that we have 2 steps. One, what we can do, let's clear all these things up. Let's take another smaller array. I think you can see the picture here, okay? And in this smaller array, we have how many elements? We have 4. Again, 0, 1, 2, 3. So in this case, I will go step by step. So this is now front F. Okay, and this is that. For now, there's no tail because there's no end of the array. Now, second step, if I insert, do the operation that insert, let's just say insert A. So what will be the change in the array if I insert one operation? The change will be the circular array. Okay, it will actually become something like this. Okay, so this was the first 4 part. So A will be inserted here. So this will be A. This will be front. That means again, this is the front, and this will be the tail because the array also ends here. So this is the difference for the first one and the last one. Then if I again perform another operation, insert, let's assume B. Now you can actually understand the change. What will happen? This will become actually different. So here, A will be in the first location and B will be in the second location. So this will become front F. It is still is the front, and then this will become the tail. So every time I insert an element, the tail will be updated. Okay, every time I pop an element, the front will be updated. Let's insert another element. Let's see what happens. Let's insert C. Okay, so if I insert C, what will happen? The array will become something like this. So basically A, B, C. The value of front will stay the same because we still haven't popped an element. The value of tail will be updated. So tail will now locate to C. So this is very normal, right? Now let's see what happens.
Can you hear me?
Yes.
So that's mean when we have no element, that there are no tail, and when we have one element, the front and tail are the same place.
Yes, every time you insert an element, you update the tail. That is it. And every time you remove an element, you update the front. So I have shown you how to update the tail. Okay, now I will show you how to update the front. So let's assume I am doing another operation. The operation is called delete, okay, or pop. Okay, so delete. So what will happen if I perform this operation from this array? Okay, what will happen? You see this array, what will happen? As I'm updating the delete, this A will be deleted. Okay, so it will remain B and C. The tail will point to B. Okay, but the front, previously it was pointing to A. Now the front will be pointing to B. So you see the first advantage we have here. Okay, we don't have to, normal array we have to shift the elements, but in circular array we don't have to shift the elements. What we have to do, we just have to shift this front and this tail. We just have to shift these two variables. Every time I insert an element from the beginning, what I did, I just shifted this t. Every time I delete an element, I shift this f. This is advantage number one. We don't have to shift any elements. What is the advantage number two? That we'll see now. So let's assume that I have this array that is that was full A, B, C, D. Now what happened is that from this array, the front is this f equals to A. Sorry, I should not write like this. Front is equals to T, that is point, and tail is equals to D. Let's assume this is the D. So they are perfect shape. Now what we're trying to do, we're trying to actually see if I want to add a new element, what will happen? If I want to add a new element, it will say that there is no space. So it will actually will not let you add. What if I remove an element? What if I delete or pop? So what will happen? The list will become something like this. And that's what actually the main advantage of the circular queue starts. If you look closely, if I delete element, the A will be gone. Okay, so the front will be updated, right? So that we can see the first advantage again, there's no shift of elements. The tail will stay as it is and the front will be updated, only this. Now, what will happen, you see, if I again insert, let's assume I want to insert from here, I want to insert, I will just take 1 minute, then we're done. Insert an element called E. Now, this is where the beauty of the circular array starts. If I want to start, enjoy E, insert E, so what will happen, the key will change. I should have actually taken the circle shape. I don't know, my mistake. This actually looks much better. So if I actually take insert E, what will happen? You see, normally the last was D, then we had B, and then we had C, right? Now, if the tail was pointing to the last location of the circular array, that is index number 3, and the head was pointing to 0. But now, after doing a remove, the head is updated to, front is updated to B. Now, if I insert E, what will happen? E will go there. This is number 1. And the tail, which was pointing to 3, it will not point to, the tail will point to 0. So now you see the advantage here, that the tail is actually pointing to location 0, whereas the front is pointing to location number 1. And now you see it, if you don't have this two, T and E, F, these two flag or these two parameters, these variables, you can actually identify where the array starts, where it ends. But if you have this two, you can always see the front starts from here. So next time I pop from B, and E is the last element. So that's how we actually circular array work. So let me go back to the slide.
Sir, I have a confusion, sir.
Yes.
So we are inserting or deleting an element from sequentially. Can we do it for, yes, sir?
I'm actually not here. Can you repeat the question?
So we are inserting or deleting an element sequentially. That's mean we are inserting the element at first 0 index, then 1 index, then 2 index. Can we do it for randomly? As
No,
like
not
I want
random,
to
not
delete
next
a.
empty space. Every time we want to delete, we see what is the front is pointing to. So we delete from the front. So initially the front was pointing to A. So that's why I delete it, pop from A, because that's how queue work, right? A came first. Okay, so this is empty. Then if I again want to pop, you will pop B, because front is pointing to B. And then what was the question again?
the question was, can we do it randomly? As like I want to initially delete the element of C, because I don't want to delete A. I directly want to delete C.
No, the method of queue, the definition of queue is that whoever comes first will be deleted first. That's why we're using queue, right? So why you will randomly want to delete C? Like, what is the purpose of deleting
Sir,
C? Yes?
so that means every time we need to update sir pop and sir push every time when you insert or
Not pop
delete.
and push, we have to just update these two variables, front and tail, T.
Yes, sir.
So remember, every time you insert an element, you update the tail. Every time you delete an element, you update the front. And that's it.
Yes,
No,
yes.
no other changes are needed. So that is the advantage of circular queue. Number one, that every time you add an element, you just have to make one change. If you insert an element, you just have to update the tail. If you remove an element, you just have to update the front. This is number one. And number two, there's no shifting operations or no memory extra calculations. Okay. So, and another advantage of circular array, that in the linear array, the problem was that sometimes even though the array is empty, we cannot add any element. Okay, because there's but in the circular array, even though the array is empty, we can add new element.